Namaste dear students, welcome to your channel Virtual Master. In the previous session we have solved few numericals and multiple choice questions related to speed and velocity of the object. In this session we are going to discuss about acceleration of the object. The topics that we are going to cover in this session are average acceleration and instantaneous acceleration, positive acceleration and negative acceleration, and also at the end we are going to discuss about the uniform acceleration and non-uniform acceleration. If you have not subscribed our channel till now, subscribe our channel, and to get the notifications of all our video uploads, press the bell icon. And to get the regular updates of all our video uploads, you can follow us on our Instagram and Facebook page. The link for the Instagram and Facebook page will be given in the description. Okay? Before discussing about the acceleration of the object, first let us solve the question that was asked in the previous session. Okay? In the previous session, we have asked you that if a person covers 2/5 of the total distance with the speed v1 and 3/5 of the total distance with speed v2, then average speed is, okay, and four options are given here. Okay, what is given in the question? A person is covering 2/5 of the total distance with a speed v1 and next 3/5 of the total distance is covering with a speed v2. In this case you have to find the average speed. Okay, now let us assume that the person is moving from point A to point B. Okay, like this, and let S be the distance between point A and point B. And as per the question, the person is covering 2/5 of the total distance with the speed v1. Okay, let us divide this total distance into 5 parts. 1, 2, 3, 4 and 5. Okay, now he is covering the 2/5 of the total distance with speed v1. That is, the person will be moving from point A to this point with a speed v1. And the distance between these 2 points is equals to 2 by 5 into s, isn't it? 2/5 of the total distance means 2 by 5 into s. Total distance is yes. 2/5 of the total distance means 2 by 5 yes. And to cover this distance he is moving with a speed v1. Okay. Similarly, the person is moving in the next or covering the next 3/5 of the distance with speed v2. That is, the distance between this point here and point B is 3 by 5 yes, and the person is moving with a speed v2 to cover this distance 3 by 5 into yes. Okay, now we have to find the average speed of the person. Now in the previous session we have derived one formula for the average speed of an object covering different distances with different speeds. Okay, we are going to use that formula to solve this problem, and the formula is VAV equals to S1 plus S2 divided by S1 by V1 plus S2 by V2. Okay, this is the formula that we have derived in the previous session. And if you have not watched our previous session, then watch our previous sessions first, because for the better understanding you should be knowing how I have written this formula, isn't it? Okay, now here S1 is nothing but 2 by 5s and S2 is nothing but 3 by 5s. Now substituting we are going to get VAV equals to 2 by 5 into S plus 3 by 5 into S divided by, and S1 is 2 by 5 into S, right? 2 by 5 into S by V1 plus 3 by 5 into S divided by V2. Okay, in the numerator I am going to take S common. After taking S common and simplifying, 2 by 5 plus 3 by 5 I will get 1. Okay, and similarly in the denominator, if you take the LCM you are going to get 5 V1 V2 will be the LCM, and after simplifying you are going to get S into 2V2 plus 3v1 divided by, okay, 5. In the numerator and denominator, s get cancelled. What is left here? And it is nothing but 5v1 v2. Okay, 5v1 v2 is the LCM of the denominator. Now after simplifying, you are going to get v average, that is average speed will be equals to 5v1 v2 divided by 2v2 plus 3v1. So the correct answer for this question is option D, 5v1 v2 divided by 3v1 plus 2v2. Okay, I hope everyone have understood how to solve this type of a question. And if you have any opinion or suggestions, then you can write in the comment section. Okay. Now let us discuss about the acceleration of the object. Okay, whenever the object is in motion and if the velocity of the object keeps on changing, then we say that the object is having acceleration. Okay, whenever the object is in motion and if the velocity of the object keeps on changing, then we say that the object is having acceleration. In another words, acceleration is the measure of how fast the velocity of the object is changing. Okay, what is acceleration? Acceleration is the measure of how fast the velocity of the object is changing. Now we can define the acceleration of the object as rate of change of velocity with respect to the time. Okay, what is acceleration? Acceleration can be defined as rate of change of velocity with respect to the time. So I can write the formula for acceleration as a equals to v by t, where a is the acceleration of the object, v is the velocity of the object, and t is the time taken by the object. Now there are different types of acceleration such as average acceleration and instantaneous acceleration, positive acceleration and negative acceleration, uniform acceleration and non-uniform acceleration. Let us discuss all these type of acceleration one by one. Let us start with average acceleration. Now what is average acceleration? Average acceleration of an object over a time interval can be defined as the ratio of change in the velocity to the time taken. Okay, what is average acceleration of an object? It can be defined as change in the velocity of the object divided by the time interval. Okay, to understand this better, let us take one example. Let us consider the object is moving from point A to point B and the object starts at time t1 second and it reaches the point B in time t2 seconds. Let v1 be the velocity of the object at point A and v2 be the velocity of the object at point B. Okay. Now according to the definition, average acceleration will be equals to change in the velocity divided by total time taken. Now what is change in the velocity? It is equals to v2 minus v1, isn't it? v2 minus v1, and the total time taken is equals to t2 minus t1. Okay. Now average acceleration is represented by the term a bar. Okay, we can represent the average acceleration with the term a bar. Here bar represents the average quantity. Okay. Now a bar will be equals to v2 minus v1, that is change in the velocity. Now change in any quantity can be written using the delta, right? Delta v divided by delta t. Okay, what is delta? Delta represents the change in the quantity. Here there is a change in the velocity. So I have written delta v divided by delta t. Okay, the formula for average acceleration is a bar equals to delta v by delta t. Okay, I hope everyone have understood the definition of acceleration and average acceleration of the object. Okay, now let us discuss instantaneous acceleration of the object. The way we have defined the instantaneous speed and instantaneous velocity of the object, in the same way we are going to define the instantaneous acceleration. So what is instantaneous acceleration? Acceleration of the object at a particular instant of time is called as instantaneous acceleration. Okay, what is the instantaneous acceleration? acceleration of the object at a particular instant of time is called as instantaneous acceleration. Okay, there is one more definition of instantaneous acceleration, that is instantaneous acceleration can be defined as average acceleration for an infinitesimally small interval of time. Okay, what is instantaneous acceleration? It is the same as the average acceleration but for a very small period of time. Okay, it is the same as the average acceleration for an infinitesimally small interval of time. So what it means, in order to find the instantaneous acceleration, we have to use the same formula of average acceleration, but that formula should be applied for a small period of time. Okay. We know that average acceleration can be written as A bar will be equals to delta V divided by delta T. So according to this definition, what we have to do, we have to make this delta t very small quantity. Okay, we have to consider delta t as the very small quantity. So we are going to apply the limits as delta t tends to 0. Okay, if we apply the limits as delta t tends to 0, then we are going to get the instantaneous acceleration. Okay, so instantaneous acceleration a, it will be equals to limit as delta t tends to 0. Now what is the formula for average acceleration? It is equals to delta v by delta t, right? Delta v divided by delta t. Okay, this gives the instantaneous acceleration. Now we know that in mathematics, limit of delta v by delta t as delta t tends to 0 can be written as dv by dt. Okay, so this is the formula for instantaneous acceleration, that is instantaneous acceleration A will be equals to dv by dt. Okay, I hope everyone have understood the instantaneous acceleration of the object. Okay, now let us discuss positive acceleration of the object. Now what is positive acceleration? If the direction of the acceleration of the object is same as the direction of velocity of the object and the velocity of the object increases, then we say that the acceleration of the object is positive. Okay, what is positive acceleration? If the direction of the acceleration is same as the direction of the velocity and the velocity of the object goes on increases, okay, then we say that the object is having positive acceleration. Okay, to understand this better, let us consider one example. Let us consider a car is moving from point A to point B. Now observe here properly. The velocity of the car at point A is 10 meter per second and at point 1 is 15 meter per second and at point 2 is 25 meter per second. Now if you observe properly, the velocity of the car is increasing, isn't it? Now we say that the car is having positive acceleration. Okay, what is positive acceleration? If the direction of the acceleration of the object is same as the direction of velocity of the object and the velocity of the object goes on increasing, then we say that the object is having positive acceleration. Okay, I hope everyone have understood the concept of positive acceleration. Now let us discuss negative acceleration. Okay, now let us discuss about negative acceleration. So what is negative acceleration? For the object in motion, if the velocity of the object goes on decreasing, then we say that the object is having negative acceleration. Okay, what is negative acceleration? If the velocity of the object goes on decreasing with the time, then we say that the acceleration will be negative or the object will be having the negative acceleration. Now the negative acceleration is also called as deceleration or retardation. Okay, the negative acceleration is also called as deceleration or retardation. Okay, to understand this better, let us take one example. The car is moving from point A to point B. Okay, now the velocity of the car at point A is 50 meter per second and at point 1 is 40 meter per second, and at point 2 is 30 meter per second. If you observe properly, the velocity of the car is decreasing, isn't it? First it was 50 meter per second, next it was 40 meter, next 30 meter per second, and next it is 20 meter per second. So we can say that the car is having negative acceleration, or the car is in retardation. Okay, I hope everyone have understood the concept of negative acceleration. Now let us discuss about uniform acceleration of the object. Now what do you mean by uniform? Uniform means same or constant. Now when the object is going to have the constant acceleration, the object will be having the constant acceleration only if its velocity changes by equal amounts in equal interval of time. Okay, when the object is going to have the uniform acceleration, an object is going to have the uniform acceleration if its velocity changes in equal amounts in equal interval of time. Okay, to understand this better, let us take one example. Let us consider the car is moving from point A to point B. Okay, the car is moving from point A to point B. If you observe properly, the velocity of the car at point A is 10 meter per second and at point 1 is 20 meter per second. Now what is the change in the velocity? The change in the velocity between point A and point 1 is 10 meter per second, isn't it? 20 minus 10 is 10 meter per second. Similarly, the car is moving with a velocity of 30 meter per second at point 2. Now if you calculate the change in velocity between point 2 and point 1, it will be 10 meter per second, isn't it? 30 minus 20 will be equals to 10 meter per second. Similarly, the change in the velocity between point 2 and point 3 is also 10 meter per second. Similarly, if you calculate the change in velocity between point 3 and point B, you are going to get 10 meter per second. Now, see, the change in velocity between point A and point 1 is 10 meter per second. Similarly, point 1 and point 2 is 10 meters per second. So, the car is changing its velocity, that is, say, changing its velocity by equal amounts 10 meter per second, and the car is taking 10 seconds to move from point A to point 1 and 10 seconds to move from point 1 to point 2. So the velocity of the car is changing in equal amounts in equal intervals of time. That is, the velocity of the car is changing 10 meter per second in 10 seconds, isn't it? So now we can say that the car is having uniform acceleration. How? Let us try to find the acceleration. Now what is the formula for acceleration? It is nothing but change in velocity divided by change in time taken. Now when the car is moving from point A to point 1, it will be having the acceleration of 1 meter per second square, isn't it? 10 divided by 10, how much? 1, right? So the car is having 1 meter per second square. Similarly, when the car is moving from point 1 to point 2, it will be having the acceleration of 1 meter per second square. Why? Change in velocity is 10. Time taken is 10 seconds. So 10 divided by 10, you are going to get 1 meter per second square. Similarly, when the car is moving from point 2 to point 3, the acceleration is 1 meter per second square. Similarly, when the car is moving from point 3 to point B, the car will be having the acceleration of 1 meter per second square. So, the car is having the same acceleration or constant acceleration throughout its movement from point A to point B. So, we can say that the car is having uniform acceleration. Okay, I hope everyone have understood the concept of uniform acceleration. Now let us discuss non-uniform acceleration of the object. In uniform acceleration, the acceleration of the object used to be constant, whereas in case of non-uniform acceleration, the acceleration of the object will not be constant. Okay, the object will have a non-uniform acceleration if its velocity changes in magnitude or direction or both. Okay, when the object is said to have the non-uniform acceleration, the object is said to have the non-uniform acceleration if its velocity changes in magnitude or direction or both. To explain this better, let us consider one example. Let us consider a car is moving from point A to point B. As you can see here, the car is moving from point A to point B. Now if you observe properly, the change in the velocity between point A and point 1 is 5 meter per second. Similarly, the change in the velocity between point 1 and point 2 is 10 meter per second. Similarly, the change in the velocity between point 2 and point 3 is 15 meter per second. And the change in the velocity between point 3 and point B is 20 meter per second. So you can observe here that the velocity of the object or the magnitude of the velocity of the object is changing. So we can say that the object is having the non-uniform acceleration. Here in this case, the car is having the non-uniform acceleration. Okay, I hope everyone have understood the concept of non-uniform acceleration. Now let us discuss few important points related to acceleration of the object. The first one is acceleration of the object is a vector quantity, which means acceleration will be having both magnitude and direction. Okay. Now the SI unit of the acceleration is meter per second square. Okay. We know that the formula for acceleration is velocity divided by time taken, isn't it? Now what is the unit of velocity? It is meter per second. And what is the unit of time? It is second. So if you are going to simplify, you are going to get meter per second square. So the SI unit of acceleration is meter per second square. Okay. Now if the velocity of an object is constant or invariable, then acceleration will be zero. The third point is if the velocity of an object is constant or invariable, which means if the velocity is not changing, then acceleration of the object will be zero, isn't it? The definition of the acceleration only tells that acceleration is the measure of how fast the velocity of the object is changing. Suppose if the velocity of the object is not at all changing, then acceleration will be zero. Okay. Now acceleration can be zero, positive and negative. Just now we have discussed that how acceleration will be zero, isn't it? Now while discussing positive acceleration and negative acceleration, we have discussed that acceleration can be having a positive value as well as a negative value. Okay, these are the four important points that you have to remember about the acceleration. Till now we have discussed about acceleration and different types of acceleration of the object. Okay, if you have any opinions or suggestions, you can write in the comment sections. If you have not subscribed our channel till now, subscribe our channel, and to get the notifications of all our video uploads, press the bell icon. Okay, you can also follow us on our Instagram and Facebook page. The link for the Instagram and Facebook page will be given in the description. Thank you very much.